All right. Well, we are now 3 minutes into our start time, and my guess is that we're going to have more people joining us in the next few minutes. But I think maybe, Bob, we should turn things over to you to get ourselves kicked off here.
Very good. Well, hello, everybody. Thanks for joining us. For those that don't know me, I'm Bob Handler. I'm the fire chief for the city of Oberlin, and I'm pleased to welcome you to the kickoff of this important process. So today marks the beginning of the cities of Oberlin's vulnerability assessment and adaptation planning process. The active participation of community leaders like yourself will be critical in the success of this process. Our goal in this process is to engage you in the discussion and gather collective wisdom of Oberlin leaders from across the community as we consider how our community can adapt and be resilient in the face of the changing climate. I'm pleased to be leading the process with the City of Oberlin Sustainability Coordinator, Linda Arbogast, and Professor of Environmental Studies, John Peterson. We also pleased to have a group of Oberlin College students working with us who will be playing a key role in coordination, facilitation, and report writing over the next 2 months.
So today's really an introduction to the climate vulnerability assessment and adaptation planning process. When we reached out to you, many of you essentially said, why me? I'm not any kind of an expert in climate change. But the fact is that not one of us is assembled here in this Zoom meeting today is actually any kind of expert in the way that the community of Oberlin can be resilient in the face of climate change. That's true of Linda and Bob and I, as well as the rest of you. None of us has been through the changes we have in front of us. And the premise of what we're going to be working on today, starting today, is that the shared community knowledge, wisdom, and planning of the group that we've assembled can really empower the Oberlin community to be prepared and to be resilient in the face of a changing climate.
So today's goals, we hope to explain the climate vulnerability assessment and adaptation planning process, introduce the community systems for Oberlin and describe the important role of community leaders, that's you, and introduce some of the key local climate hazards predicted for Oberlin.
Okay, so what are we going to do today? Well, first off, let me say how great it is to see so many wonderful faces in the crowd. Thank you all for joining us on this snowy day in Oberlin. So today we're gonna start off with some high-level conversation from John, particularly about climate change, so that we all have the same understanding. We're going to talk about what climate action in Oberlin has looked like to date. We're going to define key concepts. And we're going to talk about what this vulnerability assessment and adaptation planning process is. And we'll have small groups where all of the participants, that's you all, will introduce yourselves and talk about some preliminary climate concerns you might have. And then we're going to have some climate predictions and hazards for Oberlin specifically. So share some data that we have seen related to these topics.
So we actually thought before we'd even go into the process of talking about climate change in general, just to get sort of like take stock of where people are in their thinking right now, we thought we'd take a moment and allow people to open up your chat window in Zoom. So that's in the lower right-hand corner. And I'm going to give you a little prompt. And what we'd like you to do is just write down the first words that come to mind. So, as many of them as you can think of. We're actually going to use these to create a little word map. Our student participants are going to be working in the background to create a word map that we'll show you later. But we just want, with these pictures, with your understanding of this community, we just want you to take a moment to respond to what comes to mind when you think of Oberlin in a changing climate. So again, with your chat window open in Zoom, please just jot down your thoughts. And if you don't know where your chat window is, you should have a more button if you don't see the chat window, and you can click on chat and just type some stuff in there. So we're going to take a couple minutes to do this.
I'm sorry, John, would you just repeat our charge here?
Your charge right now is to open the chat window and just
I get that.
type the first words that come to mind when you think of Oberlin in a changing climate. Just whatever comes into your head, whatever words come into your head, Ellen, just jot them on down.
Okay, got it.
Don't overthink it. Just write down words. All right, well, I see the comment slowing down a little bit. So we're gonna sort of come back to that thought, but we wanted to just prime people's thinking. Most of us don't spend most days thinking about climate change. Some of us probably spend more time than others, but one of the things that we're hoping to really explore and gather wisdom from this assembled group is, how is climate change going to affect all of the things we care about in Oberlin? How's climate change going to be affecting the different communities, the different groups within Oberlin? And, you know, most importantly, over the course of the next couple months, as we engage in conversations, you know, what options do we have to try to be resilient in the face of a climate that's already changing now? So like I say, we'll come back to that. But as Linda said, I'm just going to take a couple moments. I'm assuming that people have a general understanding of the climate change process, but I do just want to take a couple moments to cover the basics, just so we're totally on the same page. And this actually comes from a presentation that we've developed for the city that will be on the dashboard signs soon. So, you know, the basic process, we've got sunlight striking the earth. When it hits the earth, it turns into heat energy. That heat energy escapes back out into space. That heat energy is also what drives, you know, our climatic patterns on the Earth. It's partly why Texas is experiencing the extreme cold conditions now, is because the heating of the Earth, ironically, sometimes pushes cold masses of air places where they don't normally go. And there are certain gases in the atmosphere, carbon dioxide being the one we talk about the most, that trap heat, make it difficult for it to get out. And that's what's causing our climate and our weather patterns to change over time. And obviously, human beings are responsible for emitting CO2 and other greenhouse gases that are causing that change. And, you know, that's largely as a result of, you know, transportation, heating, electricity, farming, all sorts of activities we're engaged in. As I think everyone is quite aware, the annual CO2 emissions in the world have continued to increase dramatically over the last century. You can sort of split out, you know, the kind of who's responsible in a number of different ways. This graph happens to be by country, but you could talk about it by different sectors: electrical, transportation, agriculture, et cetera. You know, but the big take-home point in this is we are continuing to emit greenhouse gases into the atmosphere, and, you know, obviously important that we address that issue of what's causing climate change. But, you know, if we look at big averages of climate, the pattern has been very clear since the 1980s. It's been very clear that our climate is already changing, and so this is kind of a fairly often shown graph. This one happens to be of August temperature anomalies, but they're showing temperatures in August averaged over the Earth relative to, a sort of average condition. And, as we all know, temperature's been going up on a global level. So from, a global perspective, there's been a clear scientific consensus for many decades about what's going on and ultimately who's responsible for what's going on. So I'm going to turn things over to Bob for a minute here.
Thanks, John. As the graphs John just showed illustrate, climate change is obviously a global scale problem. But as this cartoon makes it clear, it's a problem that requires planning and actions at all levels. U.S. participation in international agreements, such as the 2015 Paris Accord, are critical. But ultimately, all communities face the impact of climate change that is already underway at the local level. We can see that down in Texas, as John had mentioned. A plan is a proposal for doing something or achieving something. So that's what we're hoping to do today, is come up with a plan and start progressing towards achieving. There are really only two options for positive climate action. One is mitigation. This is reducing the causes of climate change, reducing emissions, and removing CO2 from the atmosphere. And two is adaptation. We anticipate the impacts that are taking place and actions to prevent or minimize any damage from those. Linda?
So mitigation and adaptations. There are a range of positive actions that communities, organizations, and even individuals can take to accomplish both of these things. Many of these actions accomplish both at the same time, and the city of Oberlin has been a leader in climate action. So let's talk a bit about climate action so far in Oberlin. So we are going to start with 2001, when the City Council adopted the first sustainability resolution. And in 2007, the city became one of the first Ohio members of ICLEI, ICLEI is an international group of local governments for sustainability. We're going to talk a little bit more about ICLEI, as they're an incredibly important partner to Oberlin in many communities, but I wanted to give you the definition of ICLEI as defined by them. So ICLEI is the first and the largest global network of local governments devoted to solving the world's most intractable sustainability challenges. Our standards, tools, and programs credibly, transparently, and robustly reduce greenhouse gas emissions, improve lives and livelihoods, and protect natural resources in the communities we serve. So in 2007, we began our relationship with ICLEI, and we continue to work with them very closely to today. And then in 2011, Oberlin adopted its first climate action plan. So we move on to 2013. The climate action plan has been revised twice since 2011. Once in 2013, and again just last year, 2019. We initiated our vulnerability assessment and adaptation planning process. Today marks the initiation, although this class has been working on getting ready for today for several weeks. I will also add that we have done 3 greenhouse gas inventories. We've looked closely at where are our emissions coming from in Oberlin specifically, and that was done in 2007, in 2012, and again in 2018. And lastly, continue implementing mitigation and adaptation strategies. This is an ongoing process, and we're all in it together. So what you see a picture of here is our climate action plan that was adopted in 2019. It's a 5-year plan. We have committed as a community to become climate positive by 2050. At the end of this 65-page document are goals that we plan to implement in the next 5 years. Because it's my job, I know there are 113 of those goals. We have some funding for this, thankfully, through the Sustainable Reserve Fund. This is money that has been set aside particularly to implement this climate action plan. Many community members, individuals, groups, institutions have submitted proposals to help us implement this climate action plan and ask for funding through the Sustainable Reserve Fund. And that's precisely what it's there for. The climate action plan, as it is right now, has an emphasis on mitigation. How can we reduce carbon emissions in our community? But there is a chapter on adaptation and resilience. At this point, that chapter is very small, but we cannot wait any longer. We know that the impacts are headed our way. They're already starting, and we need to begin the planning process.
Oh, we don't yet have a word cloud. We're going to come back to this this slide later. Our students are still working on that word cloud. All right, so let's move on for a second. So in our agenda, our next stage is to kind of talk about some of the key concepts that are important to understanding the process of vulnerability assessments and climate adaptation. Obviously, the city has a good deal to be proud of, but as Linda's saying, we have quite a bit of work to do on this process of vulnerability assessments and climate action planning. So the terms I'm going to throw in front of you are terms that I know everyone is already familiar with, but they have particular meaning when we talk about the process of climate adaptation and vulnerability assessment. So we've talked a little bit about the city's climate action plan and about this distinction between mitigation, the process of reducing the impact of climate change, and adaptation, the process of actually trying to address the fact that there's a lot of climate change in the pipeline. Again, I think most of the terms up here are terms you're familiar with, but they have particular meaning in the context of the process we're engaging in now. So I want to take a little bit of time just to make sure we're kind of on the same page in our understanding of these terms as they relate to what we're doing moving forward. So a term that I'm sure everyone is quite familiar with is sustainability. This is a concept that first was sort of widely introduced into the public lexicon in the late 1980s as a result of the United Nations report on sustainable development that defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And I'm sure many of us have heard that particular definition before. I think when the normal public thinks of sustainability, though, oftentimes they think about things that are particularly related to the environment. This is sort of a word cloud of kind of, you know, what people think of when they hear the word sustainability. And you see a lot of terms that have to do with, you know, energy, efficiency, nature, the environment, ecology, etc. For those of us who are engaged in the field of environmental studies, we tend to think of a kind of Venn diagram when we think about sustainability that has three co-equal dimensions to it. An economic dimension. In order for something to be sustainable, it has to be economically viable over the long haul. A social and a social equity dimension to it. In order for us to consider something sustainable, it has to understand and value the implications of whatever we're doing on people, and in particular, making sure that people are being treated equitably. And then obviously the ecological dimension as well. Sustainable, it has to, you know, not degrade the planet and hopefully rebuild the planet. But the point is that most people in the field think of sustainability as really the sector that overlaps when all three of these goals are working together and working towards a goal of something that can sustain itself into the future. That's when we consider things sustainable. And I think especially in the face of Black Lives Matter, especially in the face of our growing understanding of the disproportionate impacts of climate change on low-income people within individual countries, but also people living in the global South, I think, there's been a much greater and I think quite appropriate emphasis on the social equity dimensions, just understanding that the causes of climate change are disproportionately resulting from the most affluent, privileged in the world, and the disproportionate negative effects are borne mostly by the poor and by people of color. And that's an important context for us to sort of think about where we are and how we think about, our vulnerabilities and the ways in which we can plan and be adaptive within our community of Oberlin in particular. Really, this sort of like notion of this Venn diagram is really kind of a systemic notion, the idea that we're talking about kind of overlapping systems and understanding the world in terms of trying to achieve goals for many different systems at the same time, finding ways to make the economic, ecological, and social conditions, work in towards a common end. And so we're going to be talking about systems. Each of you has been assigned to a particular community system, and a system is just a group of interacting parts that share some kind of location in time, space, or function. For the purposes of the work we're going to do together over the next 2 months, again, each of you has been assigned based on areas of knowledge and expertise to one of 7 community system groups. We considered, based on consultation with ICLEI, a lot of different options for how our community might select different groups. And we could have done things a lot of different ways, but these 7 groups seem to encompass a lot of the things we think about and care about in Oberlin. When we think of leaders like yourselves in Oberlin, we could kind of think about where you might fit into some of these different categories. And so this is what we decided to focus on. Our wastewater, stormwater, and drinking water, which we'll sort of abbreviate as water when we do our breakout groups, energy delivery and production, employment, job access and business, emergency services, public health, including exercise and recreation within our thinking about public health, food supply, food access, and local agriculture, and then community and culture, including obviously our museums, but also bundling in there, are the cultural elements of our natural landscape, green spaces, and that sort of thing. So these are sort of the groups we'll be working in over the course of the next 2 months as we think about vulnerability. We'll sort of consider climate vulnerabilities and options for adaptation through the lens of these different community systems for Oberlin, and we're very, very much looking forward to tapping into the wisdom of the folks who've been invited to participate, because there are folks in this Zoom room who know an enormous amount about each of these sections, maybe not necessarily thinking of them so far in terms of climate change, but who have the knowledge necessary really to think about how these different components are potentially going to be affected by the climate hazards that we'll share with you today, and hopefully developing some ideas about what we might do about it. All right, so I'm going to introduce a couple more terms that, again, I mean, people are obviously familiar with the word resilience. When we think about resilience from the perspective of communities or organizations, I'm offering a general definition here from Brian Walker. The capacity of a system to absorb disturbances and reorganize to retain essentially the same function, structure, and feedbacks, to have the same identity. So when we think about the city of Oberlin being resilient, the climate's changing right now. Things are going to be different in the future. But how do we take what we know and we love about this special community of Oberlin and take actions that allow us to maintain that idea, maintain the things that we most love about this community in the face of the changes that are now underway? People often sort of kind of wonder about this difference between resilience and sustainability. And so here's a definition that was offered by another ICLEI community as they prepared their vulnerability assessment and adaptation plan. They made this distinction that a sustainable city can be seen as a growing, livable city that is inclusive, vibrant, well-serviced, and contains talented and passionate people. And a resilient city is one that stays that way over time as climate begins to impact it. So that's one helpful way of sort of thinking about these things. Again, you can think about these things from a number of different perspectives, but we found that to be helpful. And I will mention, we're going to draw a lot on the work of a small community, about twice the size of Oberlin in New York, New Paltz, New York, which this last year underwent a vulnerability assessment and adaptation planning process together with ICLEI. So we're really kind of looking at them as a model. And I believe we shared with you a report from them, which, if you want to take a look at it, it's kind of like a model of, at least we want to create kind of a draft of the kind of thing that they did over the next couple months. So that's why I put that up too. Okay. So a couple important additional concepts, adaptation. So when we talk about adaptation in the context of thinking about climate or other hazards we might face, we're talking about adjustments or preparation of natural or human systems to a new or changing environment, which moderates harm or exploits beneficial opportunities. So that's what we're thinking of when we use adaptation in the context of climate adaptation. And there's another related term that's going to be important to us, and that is adaptive capacity. So adaptive capacity is the ability of a system. So think of those different 7 different systems we talked about for Oberlin. The adaptive capacity of one of those systems is its ability to adjust to climate change, including the variability, the extremes, to moderate the potential damages, to take advantage of opportunities, or to cope with the consequences. And so we talk about adaptive planning. We're talking about trying to enhance the adaptive capacity of Oberlin for each of those systems. And we really want to tap into your wisdom and ideas for how we might go about doing that. Okay, another term to talk about is climate hazards. A climate hazard is an extreme climate event or a set of events that have the potential to negatively impact important systems. So things like storms, droughts, floods, extreme temperature, extreme wind. In our case, we're less worried about sea level rise, but all of these things that might impact a local environment. And what you can see in the graph on the left here is, kind of a map of, major climate hazards and how some of them differ in different parts of the United States. We're going to be focusing quite a bit at the end of our workshop today on the specific on hazards that are quite specific to the city of Oberlin. So one of the real advances in climate modeling in recent years has been the ability to get very localized in our understanding of what the predictions are in front of us. So we're going to take a careful look at what some of the climate hazards are for our particular zip code, 44074, which you can now kind of model, which is again a real valuable asset for folks like us that are trying to plan for how our particular community is going to be adaptive in the face of this.
So when we were going through this process, we had a list of climate changes that could affect our area. So we sat down and we took a look at it, and we came up with 6 of them for consideration. The U.S. National Climate Assessment identified a number of likely climate hazards that are specific to our region. And those 6 are what we're going to be focused on in our planning process. One is the changed seasonal patterns. Those are the patterns we're seeing reoccurring over the time and how they're changing. The extreme hot days, extreme winter conditions, flash or surface flooding, vector-borne or other diseases, and then severe winds. So those are the 6 that we're going to look at.
One more concept I want to introduce here, which is climate vulnerability. So climate vulnerability is kind of the opposite of adaptive capacity in some ways. It's the degree to which a system is susceptible to or unable to cope with adverse effects of climate change. And the vulnerability of a particular system is kind of a function of the character, the magnitude, and the rate of the climate hazard that it's exposed to, but also the sensitivity and adaptive capacity of that particular system. Again, a lot of jargon here, but it actually turns out to be pretty useful jargon when we start to have conversations about these different systems that we're going to be looking at. This is like one conceptualization that ICLEI has offered in sort of thinking about how a lot of these terms fit together with each other. Again, climate hazards are sort of the actual natural physical events and changing seasons, all of those things that we're sort of responding to. A risk is the sort of intersection between a hazard and its outcome on a particular system. So the damage that a particular climate hazard might cause on a particular system. And then, vulnerability is the propensity or predisposition of that system to be adversely affected. And, terms like sensitivity of the system and adaptive capacity are important there. Sensitivity is the extent of damage and disruption possible from exposure to the hazard. And as we've talked about, adaptive capacity is the sort of combination of strengths, attributes, and resources available that can be used to adapt to the increasing intensity. So again, a lot of terminology here. A lot of it you're already familiar with, but it has particular meanings in these contexts of kind of beginning to understand vulnerabilities and plan our adaptation process.
So that was a lot of terminology, a lot of information. What's the point of it? What are we doing with this? So what is our goal here of adaptation planning? Well, climate impacts are headed our way. The next 30 years of weather events will occur whether we reduce emissions or not. But without adaptation planning, these events will hit hard in a variety of ways. But if we prepare for them in advance, we have the opportunity to minimize the impact of these events, especially to those who are most vulnerable in our community. So we're going to now talk about this process, vulnerability assessment and planning process. So ICLEI, I mentioned them earlier on. They are a group. ICLEI is an acronym, but it's in German, so that's why we don't define it. But in English, it's Local Governments for Sustainability. ICLEI is a global network of more than 1,750 local and regional governments committed to sustainable urban development, active in over 100 countries. ICLEI supports sustainability policy and local action for low emission, nature-based, equitable, resilient, and circular development. Members and a team of experts work together through peer exchange, partnerships, and capacity building to create systemic change for urban sustainability. So as John mentioned, New Paltz, New York, Bob and I have had several conversations with the folks from New Paltz because they've been through this process. And I think John has had some conversations with them as well. So it's putting people together who have some expertise or some experience so that we can learn from their experiences. ICLEI has 5 pathways that of which they work. The low emission development, so that's our climate action plan. Circular development, nature-based development, resilient development, that's where we are right now, vulnerability assessment and adaptation planning. And they do all this by thinking about how to be equitable and people-centered.
Okay, the next 3 slides are kind of the planning process. So you'll notice that the process is circular and repetitive. So once we complete one, we'll get back to where we started, and we have to look at any changes that have occurred and make adaptions to any of the changes and proceed forward. The city has made progress on some of these steps. So we're looking for what changes took place, what effect did our planning have, and what we need to do to move on to the next step. Okay. The purpose is addressing the inevitable impact of climate change, protecting the vulnerable communities, combating social inequity, safeguarding what's important, making smarter, risk-informed investments, identifying and assessing hazards exacerbated by the climate change, identifying vulnerable communities, elements, like that's your systems, your assets, services, and populations, assessing adaptive capacity, and then determine how and where and when to take action. The vulnerabilities are gaps in adaptive capacity. Climate adaptation addresses those gaps.
Linda, I think you're up.
Oh, so the vulnerability assessment process. The first step, and one in which we have already taken some initiative, is to identify the local climate hazards. So there is a tool that's listed here called Temperate that ICLEI has developed. There are also other tools through the National Climate Assessment and US Climate Explorer. So these tools help you look at the data and decide which are the likely hazards to affect your community. So then we took that and created a short list of the key hazards to begin this process.
And I'll just mention as an aside here that a lot of the information that we present is based on the National Climate Assessment, which is a report that is required to be produced once every 4th year by Congress, by scientists in the United States. And it's an enormous wealth of knowledge, not just about how our nation as a whole is changing, but it has chapters on individual sort of regions of the country with an enormous amount of really valuable information about expected changes in regions like the Midwest, like the Northeast, and with a lot of good thoughts on adaptation planning for those too. So for anyone who's interested, the National Assessment is a great resource, easy to find on the web. And for those of you who, we're going to show you a bunch of climate graphs as we move on today. Most of those come from the US Climate Explorer, which is a wonderful online tool. It's actually very similar to Temperate. Temperate is sort of a tool that communities buy into. Again, Oberlin purchased a license for using Temperate to explore our local climate effects. But a lot of that same data can be accessed by anyone using US Climate Explorer. Basically, you type a zip code in and it gives you very specific information about how a localized region within the country, about the expected climate hazards within that.
So after much consideration and some support from our ICLEI representatives, these are the top hazards that we will be looking at. We have heat waves, changed seasonal patterns, extreme hot days, flash flooding, surface flooding, vector-borne disease, severe wind, extreme winter conditions, and drought. And obviously there were a lot of hazards to consider, and there are likely more that will have impacts, but our hope is that we picked the ones that will have the greatest impact.
So the next step of the process is really choosing community systems. And again, as with the hazards, we spent quite a bit of time discussing our options with ICLEI. Their temperate modeling tool allows you to choose many different kinds of systems. And we've already showed you what we've selected, and we've already sent you an email indicating which of these groups we've assigned you to. But we felt that these 7 encompassed many of the important dimensions of things we need to address within this community. Obviously, there are some that are not explicitly addressed, like schools, for instance, which are obviously critical to our community, but we're thinking that they can be fit in within community and culture and things like that. So we're hoping, we're looking at these groups as inclusive of whatever members of this, participants think is important. So anything you think is important, we're hoping we can think about that within the context of these 7 somewhat arbitrarily selected systems, but again, ones that seem very relevant to our own community. So the third step of a vulnerability assessment process is actually assessing vulnerability. And vulnerability here can be thought of as sort of the intersection between community systems and the particular climate hazards. And so over the course of the next 2 months, our students are going to be working with participants to try to extract your wisdom to understand for each of the systems, which hazards are most likely to have an impact on those systems. And again, what might we begin to think about doing about that? So again, in this process, you folks are absolutely key sources of information, but we're also tapping into things like the national assessment and plans for some of the plans that exist already within our own community, for instance, for dealing with hazards, but also these plans from other communities like the New Paltz report. And so assessing adaptive capacity, again, is sort of a process of focusing on community systems, evaluating how each of those are going to be affected, but also from this larger sustainability lens, thinking about the interrelationships between these 7 different systems, which are obviously very, very connected with each other. So we're thinking about each system, but also we're hopefully at the same time thinking about kind of community-wide implications, evaluating the community's overall ability to adjust and respond to the climate risks as they evolve. And as we go through this, there are obviously a lot of different dimensions through which we can consider each of these systems. What does it mean for administration? What does it mean for sort of budgeting within organizations, the regulatory dimensions? So these are, again, sort of lenses we hope that you're going to be able to help us think through how do these 7 different systems, how can we make them more adaptive in the face of changes that are underway. This is kind of an example of, I don't know, kind of the matrix of things we're hoping groups will think about. So if you're in the water group, for instance, there are certain climate hazards, which certain of those climate hazards we've identified, which are particularly relevant for your group to think about it. If you're in the water group, you're probably going to think about the changing seasonal patterns of precipitation, extreme winter conditions. Obviously, flash surface flooding is going to be important. Vector-borne disease might be particularly important. Storms might be important. So the point is, those little checks there are indicating just ahead of time what we think might be important things for these groups to think about. But really, we're going to rely on discussions between our student facilitators and our participants to help extract from you your understanding of what you think this community of Oberlin should be most worried about. So again, a climate risk is just the likely impact of a particular climate hazard on a particular community system. This is not from Oberlin, but this is an example of a table from the New Paltz report and they chose a different set of systems. So in New Paltz, in the city of Oberlin, agriculture is important, but the larger agricultural landscape we're embedded in is very important. The farmer's market is important, but there's not that much actual agriculture in Oberlin. So we did not choose agriculture as a group. New Paltz chose agriculture as a community system. These are their community systems. But you can see this little matrix here in agriculture. They're thinking about a set of hazards they think are most important to consider, and then considering the potential impacts, and then also considering the adaptive capacities. Again, this is just kind of an example of a table from the new Pulse report of once they'd gathered information from the community, what the community felt was the most important things to kind of focus on, and that's kind of where we're headed here. So, a vulnerability assessment is just a systematic community-based analysis of risks associated with different hazards on different systems. All right, so we communicated this in the emails that we initially sent you, but there are two important things in terms of how we hope to connect with community. One is we understand that everyone who's in this meeting today is a very busy person. And so our goal in thinking through this engagement was to think through what's the process by which we can have sort of the minimum demands on your time and still extract as much sort of ideas and wisdom from you as possible. And so what we kind of settled on is a process by which we will meet 3 times over the next 2 months. Today is that first meeting where we're trying to give you a lot of information, explain the process, begin to give you a sense of some of the hazards that we should be thinking about. So that's our introductory workshop today. Our next point of contact will be, we're going to arrange meetings with each of the different system groups. So we'll meet separately with each of those 7 system groups 2 weeks from now. So we'll work on scheduling that shortly. And then our students are going to actually interview each member to just sort of, get a sense of that. So that's sort of third point of contact. And then finally, we're going to summarize all of the sort of wisdom we get from you guys, information we extract from other sources too, and put that together into a presentation that will be delivered back to you for your feedback. So again, we designed this to try to maximize how much information we might get with you, but minimize the amount of commitment on your part. And the goal is obviously to have you share your knowledge, your insights regarding potential impacts of climate risks and adaptation opportunities related to the systems that you've been assigned to. Okay, so that's a little bit of commitment there. Okay, so we've done a lot of talking so far today. And what we want to do now is to take just a moment to allow the groups to get together and introduce themselves to each other so people begin to get to know each other, especially our student facilitators who are not as connected with the community. A lot of us here are connected with a lot of different people. I don't know several people in this Zoom room so far. We're going to take 15 minutes to do that. What I'm going to do in a moment is I sent out to you in an email the groups that you were assigned to, but I'm quickly just going to shuffle through those so that if you don't remember what group you were assigned to, I want to put that in front of you. And then we're going to open up some breakout groups and ask you to go into those groups and do a quick introduction and say something about a climate concern. We'll put up some prompts in front of you on that in a moment. Yeah, so again, the overall groups, these are the 7 groups, and I'll just quickly go through each of them with the names of participants. So just make sure you remember what group you're in. And remember we put a 1-word title on the end of these. So remember which of these breakout rooms are titled with these simple words here. And once you're in those groups, you're going to be asked to consider what role do you play in the community in connection with the community system group that you've been assigned to, and what is one climate concern that you have that relates to this system. Okay, so here's our water group. So if you're in the water group, you should see your name there. Bridget Kahn is going to be facilitating that group, and Marina is going to be a note taker for that group. This is the energy group. So mark your name there again. Leo's going to be facilitator and Phoebe's going to be note taker for that group. This is our employment, job access, and business group, or jobs group. Justin's going to be our facilitator, and Miriam and Jane. Actually, Jane's going to be in a different group today. Oh no, Jane is going to be in this group, are going to be note takers. This is the emergency services group. And Emily will be note taking, and Ian will be facilitating. This is our public health group, and Emma will be facilitating and Sophia will be taking notes. This is our food group, and Taylor will be facilitating and Claire will be taking notes. This is our culture group, and Elizabeth will be facilitating and Max will be taking notes in that group. Okay, so for those of you who are less familiar with Zoom, in a moment, when I open the breakout groups, you will be faced with an interface that looks something. Welcome back, everyone. I popped in on a couple conversations. Seemed like there was some real interesting stuff going on there. Hopefully that's sort of the beginning of our sort of next phase of this process, when we spend a lot more time listening than talking. But to kind of wrap up today's presentation, we want to make sure that we tell you a little bit about what we know about the future for climate, and share with you some information about that, and begin to get our heads wrapped around hazards. Can everyone see my screen right now? I just want to make sure I'm effectively sharing. Yes, you guys are good on that? Okay, great. So we want to talk a little bit about the future of Oberlin. And I definitely do not want to get into, nor am I a great expert in sort of, the simulation models used for climate, but just so we all have this understanding about where our future predictions come from, there are scientists all over the world who run these global circulation models that consider, the changing atmosphere, oceans, land surface, and ice, and use that to construct increasingly sophisticated models that allow us to predict the future with a degree of uncertainty, but they run many, many different models. There's not a single model. And the reason it's important to mention this is because the only way we understand the future we have in front of us is these climate models. They are basically our sole source of information for understanding the future, and they've been getting increasingly sophisticated over time. And so, they're kind of like our tools that we use for understanding the future and planning for that future. And there are, a lot of trusted parties involved in these. I mentioned the National Assessment, that's US scientists, but the Intergovernmental Panel on Climate Change, or the IPCC, is also one of the principal parties sort of using and conducting peer review of these models. Again, not to get into a lot of details on this, but obviously, as we think about the future, the great uncertainty is what human beings are actually going to do. And so they run many different simulations with differing assumptions about what humans might do in terms of the mitigation side of the equation. For the purposes of simplifying our world here, we're just going to consider two of the many scenarios they run. And they call these things representative concentration pathways, or RCPs. So over on the right here, you see different RCPs, and the term radiative forcing, that's sort of a measure of how much radiation is being trapped on Earth in these different scenarios, and that's going to affect the climate. Not important that you understand that, but the point is we're going to be looking at a lower emission scenario. The assumptions in the models run for lower emissions scenarios are that the globe as a whole begins to really control heat trapping gases, stabilize them by 2040, and then we dramatically reduce them in the atmosphere. So that's kind of like a best case scenario of what we do is the lower emissions scenario. The higher emissions scenario basically assumes that we do not solve this problem and we continue to emit a lot of heat trapping gases through 2100. So it's sort of the doomsday scenario. But those are the two sort of outliers which we're going to think about as we go through models. The neat thing is, as I mentioned earlier, that a lot of work has recently gone into taking these models, sort of global scale models that work in fairly large grid scale sizes, so over pretty large areas, and apply techniques to downscale those so that we can actually predict much more local climate effects. And so we are today, for the rest of our time together, going to be looking at some very localized graphs of what's predicted for the 4407 zip code that we reside in here. All right, so just to kind of get ourselves situated around what the future is like in terms of overall temperature in the United States before we start talking about Oberlin. What you're looking at in this first graph here is the historical data from 1981 to 2010. So this is sort of what temperature bands look like in the United States. Looks something like the agriculture maps that we get for agriculture zones. I'm going to now shift to looking at the next 20 years, and you'll see the sort of, the warm bands moving upwards. Oberlin's now increased up to, somewhere near 74-degree average August, July, June temperatures. So that's what we're looking at here. And again, we're looking at the RCP 4.5 model, which is sort of a moderate emissions model in this one. And then as we move forward towards mid-century, moving up above that temperature level, and then finally, as we move towards the end of the century, Oberlin is looking a whole lot more like, the southern states looked by that point. Again, this is under immediate scenario. The next graphs are all going to be about Oberlin. So these are maps that are for 44074 zip code. And I'm going to spend a bit of time on this first graph because we're going to look at several graphs that are very similar in their organizational structure. And there's a lot of information on these graphs, and I want to make sure that that folks understand how to interpret those graphs. So this first graph we're going to look at is a graph of the average daily maximum temperature. So temperature highs for a day. So the series of graphs are predictions of climate for the Oberlin region. And there, as I said, there's quite a bit of complexity. So I'm going to take some time to explain and sort of sequentially reveal different aspects of this graph. If you understand this graph, you're going to understand all of the subsequent graphs I show you. So for each of these graphs, what we're looking at, we're going to say a little bit about what we think is important and what it is. So this is a graph of daily average maximum temperatures in our 44074 zip code. The high temperatures on any given day usually occur in the afternoon. And the way we calculate those is just to record the maximum temperature on every single day of the year and then take an average over all of those days of the year. And what you're looking at first in this graph is historical observed data. So this is actual data. The gray bars that extend to 2014 are recorded averages of measurements made in the Oberlin-Elyria area. I'm not totally sure exactly where they were made, but my guess is it might be at the Lorain County Airport, which is a weather station that gets used fairly regularly in this region. Each of the bars is the maximum daily temperature averaged over the entire year. And the bars are showing as extended above and below average conditions for 1950 to 2014. In all of the graphs we show you, the 1950 to 2014 period essentially serves as an historic baseline condition for comparison of future temperatures that are predicted. And what you can see in this graph is something you already know, which is that there's a lot of normal variability in annual conditions from year to year. The data in any given year may be substantially above or below the average period. That's just normal year-to-year variability. Okay, what I've just added to this graph is a light gray area around the bars that is produced from a range of simulation models used by climate scientists to predict conditions in our area. But what you're looking at here might seem a little bit strange because scientists are essentially engaged in predicting backwards. They're hindcasting what the models predict for the past, and using the models to predict past conditions for measurements that we actually have is how scientists validate or test the climate models to know that the models they're creating, they can be confident about predicting the future with these models. So the important thing for you to notice is that the upper and lower bounds of the model predictions tend to include most of the actual observed data, and that gives us some confidence that the models are good. You should also notice that there's quite a bit of year-to-year variability in the actual data, with an overall trend of increasing in average daily temperatures as indicative of the climate change that's occurred since 1950. But conditions will always vary from year to year. This is why it's so important for modeling predictions to include a range of possible outcomes rather than simply showing you the average of model outcomes. All right, so I'm going to add something else here. What I just added is model predictions of the future under the lower emission scenario we've discussed. So the blue band predicts the likely range of possible conditions we might expect in the future if we very actively control emissions. So this is the lower emission scenario. The top of the band represents the highest projected value from the models. The bottom of the band represents the lowest projected values. And the blue line in the middle is the average of modeling results for the low emission scenario. So future conditions in any given year are expected to vary across the full range of the projections here, just as historical data varied across the range of what was of the bands in there. All right, what I'm going to show now is the high emissions scenario. So this again is basically what happens if we do nothing. This is what the models predict. So I've added the higher emissions scenario. In this case, the red band predicts the likely possible conditions we might expect in the future if we do a really poor job of controlling emissions. And the red line is the median of modeling results for the low emission scenario. Let me make this graph a little bit more complex by adding both onto the same graph. So you're now looking at both the high and low emission scenarios on the same graph. So the purplish band represents kind of the overlap between these models. So there's a lot of overlap. We might get the same conditions under both high and low, but you can see in general, we see, obviously higher patterns under the higher emission, higher average maximum temperatures. I'm adding this little box here with some data for the averages for 1950 to 2014. Obviously, they're the same under higher and lower scenarios because it already happened. But this gives you a sense of how things are changing depending on the lower emission scenario and the higher emission scenario. And what you're going to see in a lot of these graphs, almost all of the graphs we show you, in fact, is that there's very little difference by 2030, by the year 2030 in high and low conditions. So you can see in both cases, there's a pretty steep increase in the number, in the average daily maximum up to 2030, which is to say that even if we're really good at mitigating climate change, we've got a lot of climate change in the pipeline. And that's why it's so darn important for us to be doing this vulnerability assessment and adaptation planning, because even if we do the right thing, which we absolutely need to do to secure a good future for our children, there's a lot of climate change that's already in the pipeline, and there's nothing we can do to stop that change from occurring over the next 10 years. It's sort of just in the pipeline. So I think I'm going to go ahead and pass this on to our first student presenter, who's going to talk about another climate hazard. So I just showed you average daily maximums. There's a lot of different kinds of ways to present information about the climate. And I'm going to pass things on to Emily to talk a little bit about days above 90 degrees.
Thank you. So this next graph shows the count of days for each year when the high temperature exceeds 90 degrees Fahrenheit. This is important because hot days cause extreme discomfort and heat-related illness, especially if humidity is high and wind is light. Extreme heat events correspond with increased use of emergency services, and from a psychological perspective, extreme heat can be associated with increased aggression. Like many climate hazards, certain groups are disproportionately impacted by extreme heat days. For example, people who lack access to air-conditioned spaces, outdoor workers, and the elderly. Hot days also stress plants, animals, and infrastructure such as electric lines and roads, and increased demand for electricity to cool homes and businesses also stresses energy supply. A couple of things to notice, as with the previous graph that John showed, higher and lower emissions projections are essentially identical from now until 2030. So we should be anticipating this increase in extremely hot days either way. Beyond 2030, we need to plan for a continued increase in extremely hot days, but the low emission scenario is obviously a much more desirable trajectory. And now I'm going to pass it off to Jane to talk about local climate impacts on low temperatures.
So this graph shows the total number of days per year when the temperature dips below 32 degrees Fahrenheit, which is an indicator of how often cold days occur. This graph is important because some plants require a cumulative number of days below freezing before they can begin budding or blooming in the spring. And fewer days below freezing will allow certain insects to overwinter and breed more easily, which has the potential to affect our community, culture, agriculture, and green space in several ways. For example, a decrease in days below freezing can increase the tick population, which has the potential to affect outdoor activities as well as the spread of disease. Additionally, snow and activities associated with it are currently part of Oberlin's culture in the winter, so with less potential for snow, our community may have to find ways to adjust existing traditions and practices. Next, Marina is going to talk a bit about what we can expect for precipitation.
So this graph shows the total amount of precipitation that occurs over each year in inches. It's important because precipitation is obviously critical for agriculture, ecosystems, and for the water supply. Some key points of the graph are that, as you can see from it, the total annual precipitation in Oberlin is expected to exhibit only a modest increase relative to the other climate variables, and this increase differs very little between lower and higher emissions. What this graph of total annual precipitation does not show is the changing seasonal distribution of precipitation. So this means that like spring months are predicted to be wetter over time and summer months drier, which will likely have a negative impact on commercial agriculture. The graph that Bridget will be showing you next provides an indication of the changing extreme precipitation events.
Thanks, Marina. So this graph depicts the number of days with greater than 1 inch in precipitation. The number of days per year when Oberlin will receive more than 1 inch of precipitation is an indicator of how often extreme flooding may occur. It's important because, as Oberlinians know, the dense clay soil and the flat topography of the Oberlin landscape makes us prone for flooding. This issue is particularly relevant to planning stormwater and other drainage infrastructure, as well as members of the community who live in the Plum Creek floodplain. Heavier spring rains, which are predicted for our region, will impact the amount and types of crops local farmers and gardeners will be able to grow. Something to notice about this graph is that for flooding events, there will be very little difference expected in the outcomes for higher and lower emission scenarios until near the end of the century. So now I'm going to pass it off to Phoebe, who's going to talk a little bit about cooling degree days.
All right, thanks, Bridget. Cooling degree days are probably less of a familiar measure of climate to many people as compared to temperature or precipitation. This is because cooling degree days are used to estimate how much cooling energy is needed in buildings for people to feel comfortable, i.e. like AC. To calculate the cooling degrees on a given day, you just take the temperature, average temperature for that day, and then subtract 65 degrees from that. So if the average temperature for a 24-hour period is 70, then there are 5 degrees of difference for that day. So that's 5 cooling degrees. And so this graph shows adding up all of the cooling degrees for a year. Of course, this is important because cooling degree days are a measure of how much electricity people are going to need to cool a building when it becomes warmer outside. Specifically in Northeast Ohio, total electricity demand in the summer is more likely to peak and is strongly associated with the number of cooling degree days. So building engineers and utility companies need to plan for the increase in these additional air conditioning load necessary to meet the steep increase in cooling degree days, which is evident in this graph. Obviously, the increased demand for electricity in the summer is a cost that residents and businesses will, of course, need to plan for. And also enhancing insulation, energy efficient building codes, shade tree planting, and other measures can all potentially reduce energy use and the costs associated with these. Something important to notice with this graph is, as with essentially all the graphs we've seen, the changes anticipated over the next 10 years are pretty much the same in both lower and higher emissions scenarios. However, beyond 2040, the differences in our potential future are alarming under the higher emissions scenario. Now Justin's going to explain kind of heating degree days.
Thanks, Phoebe. So this is a graph of the heating degree days. They're used to estimate how much heating energy is needed in winter months in buildings to keep people comfortable. And in order to calculate that, the heating degrees on a given day, you take the average temperature for that day and then subtract it from 65. So if the average temperature for a 24-hour period is 60 degrees, then there are 5 heating degrees for that day. So this graph is especially important because engineers and utility companies use the annual number of heating degree days as one input when estimating demand for energy in the cold season.
Sorry, didn't mean to do that.
No worries.
Hold on, let me go back here a second. That's our, yeah, sorry.
One more, yeah, awesome. Some things to notice in this graph is that obviously the graph is decreasing in heating degree days. So in some ways, this is a good thing because it means less energy will be needed to heat our buildings. But obviously there'll be more cooling degree days as a consequence. And currently in Oberlin, most businesses and residents heat their building with natural gas. And to meet the goal of achieving carbon neutrality, the city is encouraging consumers to shift to heating with electricity using energy efficient heat pumps, which can also be used for air conditioning in the summer months. Now I'm going to popcorn it to Claire, who's going to be talking about growing degree days.
So this will be our last graph, and we really will be wrapping up in a couple of minutes. So if you're able to stick around, that's great. If you need to go to your next thing, that's fine. We'll be getting back to you. But, you go.
All right, thank you. So what are growing degree days? Growing degree days are the number of growing degree days per year is used to estimate the growth and development of plants during the growing season. Growing degrees for a given day are calculated by averaging daily temperatures on days when it is above 50 degrees and then subtracting 50 degrees from this. Why is it important? Although more growing degree days are indicative of a longer and warmer growing season, plants, like people, can experience heat stress and lose more water when it is hot. In our region, the wetter springs that we are already experiencing as a result of climate change can delay when crops can actually be planted. For example, in 2019, an excessively wet spring prevented many local corn and soybean farmers from ever planting a crop. So something to notice with the graph is that historically observed data has already indicated some increase in growing degree days over the past couple decades. We are already seeing these effects. There's been a recent shift in what our official planting zone is, and this could encourage farmers and gardeners to experiment with the crops they never thought could produce a sizable harvest before. But as the temperature keeps increasing, the growing degree days increase at a faster pace. Okay. As the growing degree days increase, eventually local weather conditions could stop being suitable for typical regional crops that we rely on culturally and economically and whatnot.
So I hope the presentation so far has begun to give you a taste of the changes in the pipeline and at least begun to sort of stimulate your thinking about how impacts might affect different systems within Oberlin. Obviously, today we were trying to give you this overview and this sort of general sense of how that might occur. In our next meeting, which will occur in 2 weeks, we'll be scheduling meetings with each of the groups to go a little bit deeper into sort of your thinking on this and your wisdom and insights into into what the challenges are going to be with respect to the systems you folks are going to be focusing on and what it is we might do about it. So sorry we went a couple minutes over today, but really want to appreciate the time and effort you guys have committed to putting into this. We're trying to limit that time, but we enormously value the input of community members and greatly appreciate your willingness to participate in a process that will hopefully be producing information that allows the community of Oberlin to adapt and be resilient in the face of the climate change that's upon us. Someone just asked if we can share slides. We will definitely be sharing these slides and all of the information with groups. We're not going to give you homework, but for those of you who are willing to look at stuff ahead of time, I think that is going to be very helpful to sort of review the graphs and think about those before we reconvene as a group. So on behalf of Linda and Bob and I want to again appreciate the time you're willing to commit to this important endeavor. So thank you very much for being with us today.
Thank you, everybody.
Thank you all.
Thanks, everyone.
So students, we should just stay on and use this as our space.